Hey everyone, it's Mr. Vargas here once again. This time I'm focusing on Math 8. In particular, I'm going to be looking at the distance formula homework assignment, 5.7, page 435 from your course textbook. Please excuse me as I'm still feeling a little bit sick, but we will do our best as always. So before we get started, I just want to remind us of what the distance formula actually is. And this is something that you guys should spend some time trying to memorize, maybe, just like we did with Pythagorean theorem. And Pythag theorem, once again, just because I want to be extra clear, it's a squared plus b squared equals c squared. Believe it or not, the distance formula actually is the same thing, just written differently. And here's how it looks. And it's specific to coordinates, so that's why it looks a little bit different. But here's the distance formula. It is the square root of x2 minus x2 minus x1 squared plus y2 minus y1 squared. So yes, in order to use this formula, we do need to know the location of two coordinate points. Just like we needed to know the location of 2 points in order to find slope. A lot of you guys remember our slope formula. The slope of a line was the change in y over the change in x, which was y2 minus y1 over x2 minus x1. So we do need to know the location of 2 points in order to use this distance formula. Looking at your homework really quick, I'll do problems 1 and 2 just to give you a jump start. Let's check out problem number 1. You are given the points 4, 5, and 2, 2. So this is actually enough information to use the distance formula to find how far this point is away from this point. To get a better idea, let me go ahead and draw a coordinate plane really quick. I apologize for my drawings as always. Let's see, 1, 2, 3. Okay, so that first point, I'll give it a color red, is going to be 4, 5. So 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5, and sure enough, that point will be right about there. Okay, this point I'll color it black, and that is 2, 2. So that would be 2 to the right, 1, 2, and up 2, and it would be right about there. Okay. So we want to find the distance between that black dot and that red dot. How far is that little blue line right there? Okay. With that said, let's go ahead and give our coordinates some labels. So we've got 4, 5, and we've got 2, 2. Let's call that first one x1, y1. We'll call that first pair our ones, our x1, y1, and we'll call that second pair our x2, y2. Okay, and that's going to help us with the distance formula. Just to write that again, it was square root of x2 minus x1 squared plus y2 minus y1 squared. And now it just becomes a matter of substituting in our points into this formula and working that down for an answer. So let's go ahead and do that right now. So I replaced my x2 with 2 minus my x1, which is 4, and that's going to be squared, plus my y2, which was 2, minus my y1, which is 5, squared. And once again, remember that this is all under the square root symbol. So let's go ahead and simplify that down a little bit. 2 minus 4 here is going to be negative 2. So we've got, this is equal to the square root of negative 2 squared plus negative 3, because 2 minus 5 is negative 3 squared. Okay. A few more steps here. It's actually getting a lot nicer. Negative 2 squared here is going to get you 4. So this is equal to the square root of 4 plus this negative 3 squared. Negative 3 times negative 3 is going to be 9. So you've got, that's equal to the square root of 4 plus 9. And that would be equal to the square root of just 13. So to get your final answer, you're going to approximate or use a calculator, because this is an irrational number. The decimals will go on forever and ever. I'm just going to cheat and use my calculator to figure out what the square root of 13 is. And when I punch that in, I get 3.6. It's about 3.6. So that's how far it is. That's your distance. Going back to our picture, that's your distance from here to here. It is about 3.6. Okay, so that's number 1. Let's go ahead and take a look at number 2, and I'll leave the rest up to you guys. Number 2 says we're given the points negative 3, 4, and 1, 3. All right, so let me draw a quick little coordinate plane of what that's going to look like. Got our x and our y, and this time we're going to be going this way. Okay, so that first point is in blue. That will be negative 3, 4, somewhere right along there. And 1, 3 would be up here. I'm sorry, let me do that in a different color. That will be in black. Okay, so we want to find the distance of that red line from the blue dot to the red dot. Okay, and we can actually use the distance formula once again. So let's go ahead and get right to it. I'll label this x1, y1, and x2, y2, and just plug into my formula. It is the square root of x2, which is 1, minus x1, which is negative 3. Here's where it gets a little tricky, plus the square root of y2, which is 3, minus y1, which is 4, and all of that is squared. Okay, so it's very important that you include the negative or the minus sign that comes with the formula. You can't forget about that. So if you have a minus, it's okay. It's okay. That just means it's going to change to a plus. So 1 plus 3 gets you 4 squared, plus 3 minus 4 gets you negative 1 squared. All right. Let's simplify that down a little bit. You get 16 plus 1, and that simplifies down even further to the square root of just 17. And just like before, I don't know that off the top of my head, so I'm going to use a calculator to estimate. The square root of 17 is actually 4.1, approximately. 4.1. Awesome. So that means this distance from the blue point to that black point is 4.1. All right. And that should do it for now. If you guys have any questions, please feel free to ask me tomorrow at school. See you then. Bye.